Good morning everyone. Today we are going to discuss about conductometric titration. In our syllabus we have to study four different types of conductometric titration. They are strong acid versus strong base, then strong acid versus weak base, then mixture of acid versus strong base, and two more are there. First I am going to discuss the strong acid versus strong base. Before starting the explanation, I am going to write the nature of the graph. Here in x-axis we write the volume of NaOH in conductometric titration that we are taking in the burette. In y-axis it is the conductance shown by the acid solution. And as you all know, the graph will be like this. Okay, and we are calculating the endpoint, the volume of NaOH required to neutralize the unknown acid. That is, this point gives the volume of NaOH required to neutralize the unknown given HCl. Okay, and how we get the shape of the graph? We are getting a V-shaped graph. Okay, strong acid versus strong base. Here we are taking HCl as the strong acid and NaOH as the strong base. So, as a reaction, the resultant equation will be like this. We will get NaCl and water. Okay, NaCl and water. Okay, and initially when we start the reaction, we take the HCl in the beaker. And we immerse a cell. Okay, and this is connected to a conductivity meter. Okay, so here we will get the conductance value in this conductivity meter. Okay, so the value will be high because we are immersing the cell in the concentrated HCl, and that is the unknown solution. So this value conductance will be high, and when we add the NaOH into this beaker from the burette, the conductance decreases. For each addition, the conductance decreases. That is, we get a point like this, and when we add again the point like this, this continues. Okay, and after certain volume, it increases. Suddenly, it increases. Okay, that is how we get a V-shaped graph. So, what is the reason for this initial decrease and then the increase in value of conductance? So, in an HCl solution, there will be a lot of H plus ions. Along with that, Cl minus ions is also there. But the main contributor for the high conductance value is the fast moving H plus ions. So, when we add NaOH, this OH minus ions will react with H plus ions of the HCl forming water. This is it. Water will not dissociate because it is weakly dissociating. So, what will happen is that the number of H plus ions in the solution in the beaker decreases. That is how the conductance value decreases till this point. What about this point? What is the specialty of this point? Because there are certain amount of HCl in the beaker that will be completely neutralized by the NaOH from the burette at this point. So that is the neutralization point or the end point. So after that, when we add NaOH, because we are not aware about the end point of the solution, when we add NaOH, that excess NaOH, that OH minus of the excess NaOH is going to give the high conductance value. That is, here the OH minus ion of the NaOH will give the high conductance value. Thus, conductance increases continuously. That is how you get the V-shaped graph. This is conductometric titration of strong acid versus weak base. Strong acid versus weak base. So, just as discussed earlier, the graph will be like this. Graph will be like this. Okay, and we are going to explain how we get the shape of this graph. Strong acid versus weak base. Here we are taking strong acid as the HCl as in the earlier case, then weak base ammonium hydroxide, which is a weak base compared to NaOH. So what will be the reaction? The reaction will be ammonium chloride plus water. Ammonium chloride plus water. Okay. Here initially we are taking HCl in the beaker, and here instead of NaOH we are adding ammonium hydroxide into this beaker. So what happens? This HCl will react with the ammonium hydroxide. HCl means this H plus ion of HCl will react with OH minus ion of ammonium hydroxide, and you will get ammonium chloride. Sorry, H plus and OH will give water. So initial high conductance of this solution will be because of the presence of fast moving H plus ions. And when we add ammonium hydroxide, the OH minus ion of the ammonium hydroxide react with the H plus of HCl giving water. So in effect, the number of H plus ions in the solution decreases, because we know that the conductance is mainly due to the fast moving ions. Here it is H plus ion. So as the number of H plus ion decreases, the conductance value also decreases. So for each addition of ammonium hydroxide, the conductance value decreases. And finally, you will get a point here, that is the end point. Here, we initially will be taking a 10 ml of HCl or a 20 ml of solution. That will be completely neutralized by the ammonium hydroxide. So after that, you are getting a straight line, a constant value continuously. What does it indicate? Because after the end point, after the full consumption of the HCl, still you are adding ammonium hydroxide because you are unaware about the end point. But this ammonium, as it is a weak electrolyte, it will not dissociate. It will not dissociate and give ions. So even if it dissociates, that will be very less. So what happens is that the number of ions in the solution, when we add ammonium hydroxide continuously, number of ions in the solution remains almost constant because it is a weak electrolyte. So you will be getting a constant value continuously because no more ions are coming into the solution. So you will get a continuous constant value, that is a straight line. So that is how we get the shape like this in case of strong acid like HCl, titrating again is weak base like ammonium hydroxide. Okay, thank you.